Hello, good morning students, and welcome back once again to another video for the class 9 gravitation chapter. In the previous video we studied about the numericals and how to solve the gravitational force between the two objects, whether it is a normal object and the earth itself or between two heavenly bodies or celestial objects, that is earth and moon. Okay. Now we will talk about another important aspect, that is free fall of an object. So what is a free fall? Suppose this marker, when I release it, it falls down and it is falling downwards because the gravitational force is acting on it. Now the thing is, the difference between a normal fall and a free fall is that when we talk about free fall, we are only taking into consideration the gravitational force. That is, if an object is falling under the influence of gravitational force only, and no other force is acting on it, then such a fall of an object is called free fall. Okay, so the motion of an object due to the gravitational force on it only is called free fall of an object. I repeat once again. When the object is falling under the influence of gravitational force only and no other forces are acting on it, then such a fall of an object is called free fall. Okay? So imagine you have two objects. One is this marker and on the other hand I have a feather, or let's say a paper. I keep both of them at the same height, and when I release it, both the objects will fall down. But which one will fall quickly? Yes, you guessed it correct. The answer is marker. The marker will fall before the paper. Okay, why? Because we have air around us as well. Because of the surface area of the paper, there is a friction force acting on it because of the air around us. That is known as fluid friction. We studied about this in standard 8. So the paper is also falling under the influence of gravitational force and the marker is also falling. But the frictional force due to atmosphere or air around us is very less on the marker, and because of its surface area, the frictional force of air on the paper is much more, and therefore it is falling slowly. So let's say we have a box. Okay, we have a box and we have sucked out all the air inside it. We have made it a vacuum box. Okay, and now with some sort of machine we are placing both the objects at the same height, and then with the press of a button we release those objects. Then now the marker and the paper will fall at the same time, because we know that the gravitational force F is equal to G m1 m2 upon d square. Okay? But in this case, mass m1 is marker and mass m2 is our earth. The same goes for this, the paper and the earth. So compared to the mass of earth, the mass of paper and mass of marker is negligible. That means both the forces will be almost equal, and therefore when both this paper will fall in that controlled environment where there is no air, they both will fall with the same velocity, or they will both fall at the same time. They will touch the ground at the same time, and therefore this example explains the free fall very nicely. That when the objects are falling under the influence of gravitational force only, then such a fall is called free fall and no other force is acting on it. Okay, so for the case of marker, we can consider it that it is free falling, although there is some fluid friction acting on it, but it is almost negligible. But on the other hand, for the paper, although it is falling, it is not free falling because the fluid friction of air is also acting on it. So you have to consider these things in mind. Okay, now instead of that, let's say that piece of paper is crumpled into a ball. Very fine ball. Now we drop both of them. So now the area is decreased, and therefore the fluid friction acting on the paper ball is also very less. So they both will fall at the same time. Okay, so the fluid friction reduces when that paper is converted into a ball. Okay, I hope the idea of free fall is understood to you students. If you still have any doubts, let me know. Moving on, acceleration due to gravity. Now, of course, when I talked that the marker or the paper ball is falling, it is moving. And we studied in the first chapter that whenever the object is in motion, it is because its velocity is changing. In the first case, its velocity was 0 and then it is changing. So let's say that this marker is being dropped from this height to this height. Okay? So this was the distance. Okay? Now I am increasing the distance. As you see, when it is falling from a higher ground, its velocity increases. I repeat once again, observe very carefully. Let's say this is the height from which I am dropping, and see, this much is the velocity, but now I have increased the height, and as you can see, as it comes towards the bottom, its velocity increases. That means acceleration is happening, or acceleration is acting on this particular object because of the gravitational force. And that is what this topic is. Acceleration on an object due to gravity or gravitational force. Because the gravitational force is acting on it, obviously the velocity will increase on it and it will have a certain acceleration, because whenever the velocity changes, we know there is acceleration. So acceleration due to gravity is our topic, and let's see how it affects, or what formula can it be used. So let's say this is our formula of force, that is gravitational force, correct? But we also studied in the second chapter, that is laws of motion, that in order to calculate force, we have F is equal to mass into acceleration. Okay, the derivation of the second law, where change in momentum upon time gives us acceleration, that is mass into acceleration. This is our second law of motion. So if this object is moving, there is a force acting on it, we have the mass, and we can calculate the acceleration, and in that case we have the gravitational force also. So in short, this force and this force will be same. So either you use this formula to calculate the force for the falling object, you use this formula to calculate the force, or the gravitational force, you will get the same answer. But we don't have the acceleration. That is what we are going to find out. Okay, so because these two forces are same, either you solve the gravitational force using this formula, or either you solve the force acting on the object with this formula. It both will be same. So we can equate equation 1 and equation 2 like this. So Fg is equal to F, and therefore what you get in the next is like this: G m1 m2 upon d square equals m into a. Okay? Now, like I said, this mass 1 is mass of the object, that is this marker. So I am writing mass of marker over here, and this is the same thing, mass of marker. And this mass 2 is mass of earth. So I am writing it as mass of earth, ME. This is how we are calculating the gravitational force. But as you can see, both of these equations are same. So I can remove this mass because they both will cancel each other out when I do the cross multiplication. So everything will be cancelled. Moving on to the next step. Now what is remaining? That is G m of earth and d square is equal to acceleration. So now you can calculate the value of acceleration. How? I will explain in a bit. This G is a universal gravitational constant. Its value does not change throughout the universe. And this is mass of the earth. Obviously the mass of the earth is also not going to change. So how do you know the distance? So for this, I will remind you once again that our earth is quite massive. Okay? And we calculate the force of gravitation from center of one object to the center of other object. Gravitational force is calculated from center of one object to the center of other object. And this is taken as the distance. So let's say that our object is on the surface of earth. So its center will be very close to the surface of the earth. So this point over here is taken as this, and this is the center of the earth. So center from one object to the other object. So as you can see, that what we have over here is technically the radius of our earth. The radius of earth. So we can replace the distance with radius because the distance is very close. So you add a few meters to it, it is not going to change because the radius of the earth is massive. I'll give you an example. You have a huge sea or a lake, okay? From that, you take a bucket of water or you add a bucket of water. It's not going to change much of a difference. We know that now the lake is one bucket short, and we know that now the lake has one bucket more. But it is not going to make a huge difference. The lake is still going to remain the same amount. So same thing is happening over here. The radius is huge. We know that the object is somewhere above the surface, but those few meters is not going to change the difference. And that is why we take the approximate value of the distance as radius. I hope it is going to answer your questions or confusion that the distance is now taken as radius. So we can replace this distance with the radius of Earth. So now we can write acceleration A is g, mass of Earth, and upon radius of Earth square. So if we have this acceleration, then we can use this formula once again to calculate the gravitational force, because all of these values will be replaced by this. So if you are given to solve gravitational force using the masses of the two objects or the acceleration, then once again you can solve this particular gravitational force acting on the object. Okay? Now all that remains is you can substitute all the values, because now we have constants over here. Mass of the earth is constant, radius of the earth is constant, and g is the universal gravitational constant, that is always constant, and therefore you can substitute all the values. The value of gravitational constant is 6.67 into 10 raised to minus 11. Mass of the earth is 6 into 10 raised to 24 kilograms, and the radius of earth is 6.4 into 10 raised to 6 meters, and that's square. As you can see, all the values. Once you solve this, you will get the value somewhere equal to 9.8 meters per second square. When you solve, because all of these are constants, and when you solve them, you will see that all these values will give you approximate this number, 9.8 meters per second square. And this is the acceleration acting on the object when it is free falling under the influence of gravitational force. So you can write in short that this acceleration is acceleration due to gravity. And therefore, this is not just your ordinary acceleration. This is the acceleration for any object which is free falling or which is under the influence of gravitational force. And whenever it is under the influence of gravitational force of Earth, then its values are this much, and therefore this number remains same on the surface of Earth. Now let's say you are an astronaut on the surface of the moon. If you are an astronaut on the surface of the moon, then you can see that the gravitational constant will remain the same, but the mass of moon will be used and radius of moon will be used. So there are different topics for the value of acceleration can change, but it will remain constant on particular planets. Okay, so this acceleration, that is 9.8 meters per second square, remains constant on the surface of Earth, and this acceleration, if the values will change if we go to the surface of the moon. That is, we will have to use the mass of moon and radius of moon. I hope it is clear to you, students. The symbol for acceleration due to gravity is not just small a, it is given by small g. Okay, so the symbol has changed a little bit from a to g. Now I know there are many confusions happening over here, so I will write all the symbols for you over here. This is the symbol for force. As always, force. It can be given as either frictional force, gravitational force, or a normal force, that is mass into acceleration. So this is a symbol for force. Okay? This is the symbol for gravitational constant. Gravity constant. Okay? This is the symbol for acceleration. Don't say that this is gravitational force. This is acceleration, and its unit is same as the acceleration that we studied in the first chapter. So this is acceleration happening due to gravity. Now I will make myself clear one more time, students, that the value of acceleration, that is 9.8 meters per second square, will remain constant only on the surface of Earth. Okay? And this value or this number will change. The value of acceleration will change if we are on a different planet. Okay? So that's all for today, students. I hope to see you in the next one.